Now, we've been in Oslo for a while, but now we're going to the western coast, to Stavanger, the oil city in Norway. And we're going to look also at materials a little bit more closely than we've been so far. Siv Helene Stangeland from Helen and Hard Architects. Would you come up here, please? Thank you. Please show us. Thank you.
Thank you for being invited to show some of our work here. I will concentrate on showing some applications on the use of the material wood in different projects. But it's more than just the application of wood, because it's, I think it's more about how a material or the components of typical or specific material inform how a building is designed or comes to a specific shape. And this has to do also with sustainability, because it has to do with how we go along with the resources that we choose to work with. Our interest for working with wood came very early in our career, because we live in this small city where there is a lot of old log houses like this, and we got some work to do there, renovations and transformations of tiny houses like this. But we discovered some interesting aspects with log structures. That is a massive timber structure, which are, of course, limited in a way that they are just as long as a tree are, and in Norway they are not so long, so the space are very tiny, and if they want to have a bigger commercial space, there will be a lot of separation walls or columns. So the chance or the challenge here was to create a column-free public space for this bakery. And we did this by sewing together the old log structure with kind of steel protheses, so that they would work as whole wall beams. And thereby you could both read the spatial organization of the old house floating over you, and you could free the space of columns underneath. When starting to build new projects, we were interested in how we can achieve these qualities such a massive timber structure has. And there is a lot of new products on the market called massive timber elements, prefabricated elements. Some are with glue, some are without glue. We chose to take the challenge to make it without glue. These are just panels that are layered over each other, and they are bolted together with they're bolted together with a wooden bolt, which keeps them together, but of course then they are not spanning that long. So when we're going to span over bigger areas, like in this space, we needed to challenge the production of these elements so that they could do that. And by turning the layering inside out, we could extend the diagonals and combine more elements and stiffen the structure. So this was a kind of going into the prefabrication, but changing the way it was made and making a specific element, still using the same way of doing it as they always do. These are Holt's 100 elements, they are called. Another research into how structure can become the main spatial element or designing element is an experiment we did in this library in Vennesla. It's a small town in the south of Norway. It is both a coffee, it includes an existing cinema and some educational facilities in the city. It's lying in the main street and adjacent to the main square, where the main idea was to create a fluid continuation of this square into the library. Of course, then meeting first the more public zones with coffee and reception area, and then as longer you enter the space, the more silent it is, and you can study and find your quiet space in the end. And so here you see the two adjacent buildings and the ribs that are just spanning in between, and they are kind of adapting to following the different heights of the neighboring hill building and the site that we could build on. Another important intention in this project was that we wanted to include the infrastructure so that it was nothing added to, but that these rib elements could also take the ventilation, the sprinkling, the signing, the lighting, and all this stuff that you need to control. Starting with a very simple structure, columns and beams in glue-laminated timber, then we added different layers of infrastructure, but still attached to this ground, this basic structure. Furniture are added, and the different program that is needed in the library. It was crucial to build a prototype for this so that we could see how all the components together would fit. So although this library consists of 27 very different ribs, and it was quite easy to control it when we first did the prototype. We think it's an interesting exercise trying to find out how you can make a building be informed both by bottom-up, as we like to call it, that means the user perspective and everyday life of a building, and the top-down parameters that are the site, the laws, the neighborhood, and it seems to function when you kind of start in the middle, and if you can work with a kind of adaptable composition of space that can take information from both sides. The building has extensive use of timber or wood. It's not only the rib structure, it's also the walls, the ceiling, and the elevation shafts even. The cladding, both the roof cladding is of pine heart, the screening, sun screening is panels of glue-laminated timber, and all the interior is made of plywood veneered birch. It's of course the best for us to know that the building is in use, and it is in very much use. It's even people getting married there. We think that its success lies in a kind of scale that it reaches, both the silent spaces for more private study, but that it also has this generosity provided by the big space, which is a kind of communal space that can be used for a lot of different activities. The project also got the National Award for Sustainable Good Building Design in 2011. But in our research, we thought that it was a lot of work to, although these elements look like simple ribs and they appear like complete elements, they are composed of very different elements, as you have seen, and we have been researching into how you can also prefabricate more of these parts to make the montage inside more easy. And we have been inspired by, for example, this very low-tech way of using the material wood. This is a picture from the 16th century showing how boat builders cut out the parts they need to construct a boat without any elaboration. They use the growth patterns in the tree to manage what the structure needs. And so when we were invited to make this small play pavilion in London Victoria and Albert Museum, we wanted to test how this use of the natural tree could maybe be a new possibilities using digital media that we have today. So instead of starting with a shape or a design and then finding out how to do that with the material, we went into the forest to pick the tree as a start point. And these are very special trees. They are used for pollarding, so they are very thick stems, often hollow. We cut them in half and we scanned them so that we could work with them as a digital mesh. And then we could explore how they could be combined and adjusted to each other so that we didn't need any other extra steel reinforcement or fittings. And then, of course, we could also program a robot to mill the interior of the pavilion so that the surfaces inside are completely plain, and also integrate climbing grips, and even there is a poem to be read inside. So the intelligence of the tree is difficult to find in our industrial world, but there are some really interesting elements that we find and try to make use of. These are box elements. They can span 16 meters, and they can also include insulation and infrastructure. And we wanted to test how the use of such an element could be applied in making this very simple, small projects, an entrance for 2 big office blocks, where the only program was to make 2 entrances from each side. And again, we had to challenge the industry because the elements were not planned to be used like this, of course, so they are reinforced, but that has in fact made a new product for the firm that produced them, so they were very happy in the end. We stacked them and we twisted them and we closed them off where we had to because of fire restrictions, and that's also why we let an opening for smoke evacuation and lighting. We used parametric modeling to find the best geometry. A lot of iterations were done to find the final shape. And interesting is how this is then put together in 8 days, and you have the finished surface inside, and even the furnitures are included in the structural build-up. So it's a very efficient way to build with high quality. And it's fascinating how much you can do out of a simple element like this. Of course, these are very small experiments, but our real interest lies in trying to implement this way of thinking and building in bigger projects, and for example, large-scale housing, where we have used quite a lot of massive timber. Now I'm showing a project which is not about that, but it has extensive use of timber anyway. And it's 3 towers that came. It was possible to build high because of a Viking grave that you see in the middle of the picture, which the municipality wanted to preserve. So the buildings around it had to be very low, and the developer then got to build very high at the back of the site. But it started off with a wall in the regulation plan, and we negotiated to break up this massive volume into 3 towers and instead build it a little bit higher. The idea of these 3 towers is that they become as transparent as possible, both in volume and in the footprint. So by making this prismatic form, we can let the view get through or along in diagonals. And it's only the core with stairs and elevators and entrances that comes down to the ground, and the first apartment floor is then lifted 4 meters. The idea was then to give this space to the neighborhood and create a social gathering place underneath the towers, where we also gathered the play equipments, and which are designed specially to fit into these concrete fins that are part of the core structure. And here you see also the effect of lifting the apartments to provide more view to the mountains behind the buildings. There is a lot of intentions about sustainability here that I'm not going into, but I think we found a very nice way of also building or planting more trees, which was part of the sales program for the project, that each flat could got an apple tree to take care of in the garden, so that the relation between the people living there and the ground was kind of established, and they also got a bicycle, in fact. So here you see the whole structure of the building, the core built in concrete, that are making the different apartment divisions, but also extending down to the playscape at the ground level. I want to show that this building was in fact calculated and planned in timber, and we got so far as to show that square meter price was the same as building it in concrete, but in the end the developer didn't have the courage, so it will be another time. But there is wood used as a cladding on the concrete core, and I think that makes a big difference. And it's a bit interesting that it makes such a big difference, because I think the concrete would feel like a cold space under these buildings. The whole facade structure is a framework of timber, and also the cladding is a wood product. Yeah, so as an ending point, I think it's, beside being a very environmentally good material to use, I think it's more about being very conscious about which material and how we use materials. And we are very occupied about making the use of material and the structure visible, because I think there is another quality when you can read how something has been growing or how it is built, and that's exactly why we are fascinated of timber, because you can read the growth pattern of a tree, and it brings the scale down to a human scale. Thank you.
Thank you, Siv Eleni. You've shown us how you are actually